Okay, let's continue on with chapter 26, the second half of the exercises. Number 16 reads internal rate of return. So the internal rate of return method is used by this construction company in analyzing a capital expenditure proposal that involves an investment of $113,550 and annual net cash flows of 30 grand for each of the 6 years of its life. Determine the present value factor for an annuity, which can be used in determining the internal rate of return. So let's make this very clear. The first thing we're calculating is the present value factor. All right, and then letter B, using the factor in A and the present value of an annuity table appearing in the Exhibit 5, determine what is the rate. Okay, so the first thing we do is calculate this present value factor. So the amount to be invested, and it said it was $113,500. The annual net cash flows is 30, and that equals our 3.785. Before we move further, does that calculation remind you of anything? Does that calculation remind you of what we've done so far in just this chapter? This present value factor calculation. Amount to be invested divided by the annual net cash flows. If you remember, that would also be what we would call the cash payback. So if you know the cash payback and we calculate that and we figure out how many years it is, so in this case we could say it's 3.785 years, but we're also calculating the present value factor. Okay, so then going to Exhibit 5 in the chapter, which is on page 1319, and you take the 6 period, so you go down to 6, and you scroll across until you find 3.785 or close to it. And you notice it hits it spot on, of course, 15%. So what this is telling us is this present value factor aligns with 15%. So we can determine the internal rate of return on this proposal is 15%. All right, let's move to number 19. Net present value method and the internal rate of return. Buckeye is proposing to spend $186,000 on an 8-year project that has excuse me, I have to read this a little closer. It has an 8-year project that has estimated net cash flows of $35,000 for each year. So letter A, compute the net present value using a rate of return of 12%. Use the present value of an annuity table appearing in Exhibit 5 of this chapter. Okay, based on this proposal, is the internal rate of return more than 12, 12, or less than 12? All right, so number 19. So first, letter A, it says, compute the net present value. Okay, the present value of these cash flows, $35,000 every year. Going to the table on Exhibit 5 again, which is on page 1319, and we are looking for 8 years at 12%. So 12%, drop it all the way down to 8%, is 4.968. Make sure you take the time to look at these exhibits and use these charts so that when we get to the test, you're familiar with them. So we calculated out the amount to be invested. So the net present value here, in this case, for the first time, is a negative. So knowing that it's not 12%, it's certainly not greater than 12, it is less than 12. If this was 0, it would be 12% exact. If it was a positive number, it's greater than 12. And that's why we go to the internal rate of return. Okay, we know it's not meeting our 12% rule, but how far below 12% is it? Is it just, a hair under 12, or is this thing significantly under 12%? So that's why we jump to the internal rate of return. So based on this analysis, we know it's less than 12%. Determine the internal rate of return by computing the present value factor. So first, again, let's do that cash payback right here. So Amount to be invested, $186,000. Cash flows, 5.35. So now, if we go back to our exhibit 5, 8 periods again, looking across at 8 periods, 5.35 aligns with 10%. So we knew it wasn't 12, we knew it was below 12, but how far? By calculating this, we now can say it is 10%. Number 21, net present value, unequal lives. Bunker has 2 competing proposals, a processing mill and an electric shovel. Both pieces of equipment have an initial investment of $750. The net cash flows are as follows. And it says here, the estimated residual value on the processing mill at the end of year 4 is $280,000. Determine which equipment should be favored, comparing the net present value of the 2 proposals and assuming a minimum rate of return of 15%. All right, so we need to cut this thing off at 4 years because in order to keep it comparable, the electric shovel stops at 4 years. So looking at the processing mill, because it's different amounts every year, it's not consistently the same, we have to use the present value of $1. We can't use the annuity. So every year we have to calculate using the 15% column, going down and calculating every single one of these and getting to a net present value. The processing mill has a residual value of $280 at the end, so we will get that back also in year 4. So year 4, there's 2 calculations. Okay, so our net present value at the end of the 4th year is positive by $196,000. So we know that we're doing much greater than 15%. To what level? We don't know that. The electric shovel, again, calculate all the cash flows. And again, we also have a positive net cash flow, just slightly under the processing mill. So it says determine which equipment should be favored. Both of them are positive. Both pieces are acceptable. However, the processing mill is probably the one that we would want to favor because it's slightly better. All right. Problem 1A. Problem 1A. It asks you to calculate the average rate of return, the net present value for this company. There is 2 capital investment proposals, the front end loader and the greenhouse. For each project requires an investment of $75,000. Straight line depreciation will be used. No residual value. The company has a hurdle of 12%. Compute the following. First, average rate of return. Rate of return would mean we're looking at income, not cash flows. Average rate of return is income. So the first thing we do, front end loader, $56,250 divided by 5. The investment of $75,000, and there is no residual value, so 75 plus 0 divided by 2 gives us a rate of return of 30%. Letter B, and ironically, that's the exact same answer for both front end and greenhouse. Letter B, the net present value for each method. Okay, so once again, if you notice, unfortunately for the front end loader, it is a different cash flow for each year, which would mean we got to calculate this manually for each year. The greenhouse, on the other hand, has the same cash flows for each year, so you could have used an annuity. For this solution, they're only using the one with a present value of $1 because we had to list them all out anyway for the front end loader. So since we have the information, we can use it also for the greenhouse. So calculating the net present value for the front end loader after looking at the amount to be invested is $24,000. The greenhouse is $19,000. And I guess based on that, we would want to use, or we would select, the front end loader. And I think we've answered all the questions for problem 1A. Problem 2A, continuing on, it's cash payback, net present value. again, each project requires an investment of 900 grand. A rate of 15% has been selected. Again, that hurdle rate. So letter A, cash payback. Cash payback. Simply, it's a $900,000 investment. You can eyeball this one. Plant expansion, it would take, what, 2 years. Retail store, also 2 years. Doesn't take a lot to figure that out. Letter B, the net present value. Okay, again, plant expansion, these are cash flows. We would have to look at is it the annuity or the lump sum? Well, in this case, it would have to be the lump sum because it's a different amount every year. Same with the retail store. So using our present value factors of a lump sum of $1 right here, we can calculate again the present values for both the plant expansion and the retail store. If you start to notice, it's very much the same thing again and again and again. It's just going to make sure you know what to look for. Different cash flows, it's going to have to be that the first present value factor tables where it's the present value of $1 of a lump sum. If it's always the same cash flows, you can use the annuity table. Making sure also, are you looking at cash flows or are you looking at operating income? When we're doing the average rate of return, we're looking at operating income. If we are looking at cash payback or net present value calculations, we are looking at cash flows. And then lastly, problem 4A. Problem 4A. And again, they want us to calculate net present value, which we've done now many, many times, but also to add to that the internal rate of return. And you're looking over this problem, you see the two columns, wind turbines and the biofuel equipment. And what should that make you do? Smile. There is all the same cash flows, so we can use the annuity table. We don't have to calculate it 4 times. The wind turbines require an investment of $887,600, while the biofuel equipment requires an investment of $911. Compute the following. The net present value. Okay, use a 6% hurdle. Okay, so we can do that. We can use the the annuity table. So knowing that, we can take all 280 times this factor found in Exhibit 5. We have a net present value of $82,000. Doing the same for the biofuel equipment, we get another net present value, a much higher one. Letter B, it just reads, determine the internal rate of return for each project, computing a present value factor of 1 and using the present value of an annuity table in Exhibit 5. So first, the present value factor. Excuse me, let me step back here a minute. In Part 1, we calculated the net present value. Part B, it says, calculate the present value index. This is the first time that we've done that. So present value index is a calculation that we honestly do not do often. I included it in this problem because I wanted you to see how you calculate the present value index. We don't use it often, but I want to make sure you don't confuse it with a present value factor. Notice on the index, we're looking at the present value of the net cash flows. It would be $970,200 or $1,039,000 divided by the amount to be invested. So just make sure you understand that that is a different calculation than the present value factor. So this would be like the cash payback amount to be invested, again, $887,600 in this case. For the first one, there is cash flows of $280 every year. This one has cash flows of $300 every year. So in a way, we could say for the wind turbines, the cash payback is 3.17 years, or the present value factor is 3.17. Knowing that, and again, because this is an annuity, we can go to Exhibit 5, found on page 1319. It, again, is 4 years, so we can only start at the far left-hand column, 4 years, going across, and finding 3.17 is 10%. Continuing on to find 3.037 is 12%. So now we have calculated the average rate of return, uses the operating income, cash payback, using cash flows, the net present value, cash flows, just making sure we understand, do we use the lump sum tables or the annuity tables? The internal rate of return, which you must calculate the present value factor. We know what that resembles, and then we can ultimately get the exact return that this proposal provides. That concludes chapter 26. My suggestion would be that once you have gotten through all of these videos, both of them, you look once again over all the exercises, making sure you understand them, having read the chapter before you move on to the next part of the assignment. Thank you. Have a great day.